driven.
Hello everyone, this is Data Driven Chat, and today I'm very happy to present Sakshi Mishra. So Sakshi is a researcher in energy and AI at the National Renewable Energy Laboratory in the US. Hello Sakshi, how are you today?
Hey Ganna, I'm good. Thank you. Thank you for having me here.
Thanks a lot for finding the time. So, just to kick off our discussion. So you're working in on the intersection of energy sustainability and AI. So can you tell us how did you get into this area, interdisciplinary area? So tell us a little bit about your personal journey. How did you become a researcher in energy and AI?
Sure. So my current research interest sort of got built up in three separate stages in the past decade. So I really started out as a keen interest in renewable energy field during my undergraduate education, which was in electrical engineering. And I distinctly remember taking classes on distributed energy resources. And from day one, I was intrigued and sat in the first row for the whole semester and super interested, getting A+. And so eventually, pursuing the same field, I landed my research internship at Australia's Deakin University's Renewable Energy Lab. And my experience was just very, opening my horizons in understanding it was a hardware lab. And then I was working on building software application as well as connecting hardware systems. And so that's how I was, by the end of my undergrad, I knew renewable energy is the field I wanted to go into. And then when I moved to join graduate school here in the United States, I kind of naturally gravitated to join the interdisciplinary degree called Energy, Science, Technology, and Policy. And it was for widening my horizons from just electrical engineering aspects of clean energy to its economics and policies aspects as well. So I wanted to gain a holistic grasp of its current state. And while pursuing this degree at Carnegie Mellon University, I took up a couple of courses on data science and machine learning. And Carnegie Mellon University is kind of known for its computer science and robotics strengths in general. So it's a very nurturing environment. And that's how I got introduced to the fascinating field of data science and AI. So after graduating from CMU, I took up a role as grid planning engineer at an electric utility because that was kind of my core educational focus, power systems and electrical engineering. Mm-hmm. But I chose to continue with what I started at CMU. That was my education in the AI field. I did it through online courses and starting a collaborative research project of implementing ML-based, machine learning-based prediction algorithms for solar resource forecasting. So initially it started out as a side hustle. I'm taking evening classes and working on this, but eventually I moved to National Renewable Energy Laboratory, where I was able to bring together my day job and side hustle into one major focus, which is energy plus AI field. So I guess to summarize, I would say there are so many brilliant researchers or practitioners working in the clean energy field today. And same way, there are hundreds, if not thousands of brilliant minds pushing the boundaries of AI field every single day. But I see that there exists a gap understanding and application of these cutting edge AI methods to the clean energy field. And this gap needs to be filled, or I should say must be filled, in order to utilize AI for solving climate change problems. And that's where I'm focusing my current research efforts.
Mm-hmm. Sounds fascinating. Especially I'm curious about the initial choice of electrical engineering. That's not really very common choice, especially for a female, you know. And we will talk a little bit more about STEM and why you have decided to go into this kind of data-driven profession. But before we do that, there is obviously a lot of information about you online. But for people who are not familiar with what you do, if you could pick one most important thing you have achieved during your career, what would it be?
So it is getting my research on campus load predictions using deep learning deployed in a real-time setting for the advanced analytics applications at the National Renewable Energy Laboratory's Intelligent Campus program. So as a researcher, I work on conceiving forward-looking ideas, then researching the algorithms and building prototypes. And oftentimes I stop this process by publishing the findings, and that's where it kind of sits. But to see the prototype deployed in real life settings as a useful addition to existing technologies or tools is something I value a lot. So it also gives me an opportunity to find the shortcomings of the prototypes, which I built during my research phase, like how they apply to the real life situations, and then iterating over them to make them better fit for the needs of the audience. So I was having a prototype built, deployed on US National Labs campus is something I consider as one of the things I have, I guess, added a real life value to, you know.
So. Sounds fascinating, and you're working in a really important field. But in terms of what you are currently, I appreciate they probably cannot tell us everything about what you're doing at the moment. But in terms of what you are currently working on, can you tell us a little bit more about your current work and kind of what keeps you awake at night? What makes you excited?
Mm-hmm, sure. So I'm currently exploring reinforcement learning's application for district level distributed energy resources controls. So essentially implementing an additional layer of intelligence on smart buildings operations. So we hear this term so often. It is a little different from a data science field, but in energy field, it's a common application called smart building operations. So that's kind of being implemented all over the world, especially the developed nations. There are smart building operation systems which are getting rolled out by commercial manufacturers, for example. But what I want to explore is really a coordinated operation of smart buildings, 20, 30 buildings in a big city coming together. If they can speak to each other and then dispatch the renewable energy resources in orchestration, they can save a bunch more energy from being wasted or optimize its usage. So that's where I see reinforcement learning's application to be pretty good, and that's what I'm exploring. So this is kind of like the work I'm doing, but in general or a broader sense, what keeps me awake at night is the tremendous possibilities that exist when the sustainability and AI fields come together. There are multitude of such avenues which are still unexplored and kind of underutilized in real world, where we can just take existing AI algorithm which is available and then apply it to energy field and then see much more efficiency gains or much more optimized operation. So that's kind of my focus.
So just to kind of clarify for the listeners, so are you working on the modeling side, or are you working on developing kind of sensorial capability? Because there are obviously various sensors and devices that we use in buildings. Like, for example, in the UK, there is a real trend for, say, retrofitting the kind of old buildings with new tech to make them a lot more energy efficient. So there is a lot of work in engineering kind of on developing the technology to make the buildings more green and more sustainable. And at the same time, there is a lot of work on modeling, right? How do you actually analyze the data that comes from different parts of the building, so even parts of the city, and how do you optimize energy use? So your work is it more on kind of device side, or is it more on modeling side, or a little bit of both?
I would say it's 90% on the modeling side. So I take the data which comes from the devices and then analyze and do the optimization part on it. So And then there was a recent project which was kind of overlap between the two, where it was automated metadata tagging for building sensors. So it was like the raw time series data which comes from sensors is not usually tagged properly. There is not like industry-wide standardization there. So based on the vendor or manufacturers, they add some system of labeling that time series data, which is not really interpretable by machines or even humans who have not tagged it themselves. So this project was like taking that time series data and then applying machine learning algorithms to first cluster it and then label it such that the labels are standardized, which can be understood and then saved into the database and pulled out for doing analytics neatly metadata. So that was kind of overlap project, but 90% of the time I would say I focus my efforts on the modeling aspect of it.
Yeah, that's great, and definitely very, very important work. So you have described your personal journey and how you went to Deakin University and CMU. So a lot of people who listen to this podcast, they are aspiring data scientists, and they're interested in different applications of data science, including energy. So we had several researchers on the podcast who do sustainable sustainable analytics. So they work they don't quite work in energy. I don't think we had anybody who works in energy, but we had people from biosciences, we had people from climate change, climate science. So imagine that you are talking to someone who is just an aspiring data scientist. Can you give some tips on, where to start if someone wants to learn about how to get into data science or AI in application to energy sustainability? What is the best path? Should they also start with a degree, or should they take some online courses? Like what would be your advice?
Yes, sure. So I think it depends on what point of time they are in their career. Are they starting out with undergrad education, or they are done with the undergrad and master's degree and they are looking for pivoting? So let's say if they are done with undergrad degree and they have a degree in chemical engineering or biosciences or electrical engineering, and they really want to like get into this sustainability and AI field where they're looking for building data science applications. So a tangible, good starting point is to get oneself somewhat familiar with coding. So even if you're not holding if you're holding a role like project management or customer facing roles in this industry, having a basic familiarity with the hammer, which is the code here, makes you a lot more effective. And if they're looking for like rolling up their sleeves and continuing to build the advanced modeling and analytics software tools, then a good starting point really is to do like 6 months or 3 months of like boot camp environment setup where you're really getting acquainted with basic coding tools if you want to like directly contribute to the software building process. Mm-hmm. So once you have gotten started, it's like I have seen one, because I dabble between both the fields, energy as well as AI. One thing I've seen is many energy experts, they have a ton of knowledge and they even get started with programming. They are like intermediate or beginner level, but they always see it as an intrigue, like they're intrigued by AI field, and then they see, oh, AI is something I have not studied. So it's like, it's so vast that I am not sure if I can ever learn all the aspects of AI. It's just picking the niche. I am working with deep learning, or I am right now working with supervised machine learning, and then getting started there. So my advice really is that don't hold yourself back thinking, oh, there is a lot to learn and I can't get started right now. Just get started. You just have to have basic programming knowledge, Jupyter notebooks, if Python is the chosen language of programming. If a Jupyter notebook, you're able to operate and write a couple of functions, your domain knowledge is so helpful that you can bring just little bit understanding of programming and functions with your domain knowledge and still build something which has value to offer. So getting started early is something I think should be considered rather than holding back thinking AI is like this stuff or new cool thing we can get into. So I think that's for the people who don't come from data science background and want to pivot into this field. And if they are already data scientists, then I think one basic thing or one fundamental thing which adds a lot of value is collaboration, because for data scientists and people coming from like AI background, they already know these aspects of how to give life to the solution, that this is my this is the diagram I can make for them, and if I give it to them, they can always code it for me, right? But the understanding they are lacking at this point is the field knowledge. Oh, this is how buildings are wired. This is how you will see HVAC system. So for that particular reason, like just picking the brains of energy domain subject matter experts or collaborating with them can make their process of building meaningful code base or solutions way more effective. Yeah, I guess those are the tips from two different angles, I guess.
Yeah, sounds great. You mentioned the domain knowledge, and also you also mentioned data and the availability of data at present time, and how important it is. So, just to expand on this a little bit, why is understanding data particularly important for reaching sustainable future? And how did data change the way we think about energy in the last few years, in your opinion?
So I would say understanding derived from data is no doubt extremely important in building a sustainable future of the planet. So maybe let's look at it from different time scale perspectives. So if we are analyzing the trends over multiple decades or a century, maybe it gives us a close to accurate assessment of how we are doing as a planet, which is not good looking at the climate change trends right now. But so that level of meta analysis of data for multiple years or decades. So this is giving a scientific basis to unite the opinions of big and small decision makers who can all focus their collective efforts in positive direction for solving climate change problems, and energy being a subdomain of that whole climate change issue we are dealing with as a humanity. Then if you look at a slightly smaller time scale, which is analyzing data for a few years. So on this time scale, it's very helpful in planning the energy infrastructure. So for developed nations like United States or UK, so insights from data makes the process of upgrading infrastructure much more effective, because infrastructure is kind of aging now. It's a century old in US. So though it's being upgraded, is it the best way to upgrade it the way we are planning? No, we can bring in data from past few years, analyze, and does it make sense to build a solar power plant here or maybe in adjoining state? If we built it there, the energy is going to get to the load faster, or it doesn't have to travel that much distance, saving the losses. So if we think about that, data can provide all those insights when analyzed over a few years time period. And in the context of developing nations, analysis of the data from places where the infrastructure has already existed for long can improve the understanding what works or what does not. So in other words, developing nation as they are, because energy need is going to increase more and more. Population is increasing as new appliances, cell phones, computers, laptops are reaching more and more people in developing nations. The energy needs are going to increase. So why do they have to reinvent the wheel? They can always learn from the mistakes done in the Western world while the infrastructure was getting developed, which ended up basically in the climate change issue, where there have been emissions. So if the data is analyzed and proper insights are withdrawn from that, then developing nations can take it as a model. Maybe we don't have to build big coal power, nuclear, coal or fossil fuel based power plants. Let's start with just renewable energy big scale power plants, right? So that's like a medium term time scale. And if we talk about short term time scales for electric grid specifically, capacity to gather and analyze data is in the operational time window can be of much help in reducing the use of peak shaving generation plants that are heavy contributors to greenhouse gas emissions. So if we are able to analyze, let's say, if I can predict how much solar or how much wind is going to get produced in coming 1 hour, coming 2 hours, and predict that with more certainty, that would mean that when time in the real time frame, they don't have to turn on diesel generators just because my prediction was too much off. So that way, lots of carbon emissions can be reduced by analyzing data. So data does hold a big role and power in helping gain the sustainability goals of the future.
Mm-hmm. Yeah, I mean, you talked a lot about kind of macro level. How do we change as a society, as a planet even? But I'm just thinking about, just to kind of expand a little bit on what you said, and I'm just wondering what you think about this. So I have a little bit of a vested interest in this topic because I do so my research is, for example, on human behavior. And I think that, like from the personal households or personal consumption of energy or household consumption of energy, data can sometimes be confusing. So I'm just wondering whether you think there is a possibility to somehow correct people's understanding of what energy is. So let me just give you a very specific example. So I have these friends who recently installed energy, energy saving light bulbs in their house. But the problem is that they keep these bulbs on all the time. So on the one hand, they did the right thing, right? So they did the right thing. They're thinking, okay, we need to be sustainable. We need to kind of keep the lights on. But, at the same time, the fact that they're now spending a lot less on, a lot less in terms of their household spending on energy kind of confuses them in thinking that, we can actually keep it on all the time. Another example that I can give you is, again, I have two friends who are both lawyers, and they spend a lot of time. Well, now they spend time at home, but before we had the coronavirus, all these coronavirus issues, they spent a lot of time out of home, and they have a dog. And they feel really bad about leaving dog at home, so they keep the TV on all the time. So for the dog, so the dog does not get bored. So, and these are anecdotes, of course, and we laugh about that. But that kind of, I think this confusion about that you can, make progress in one part, but then kind of a complete regress in the other part, is very, I think, is very typical for many households. So do you think, like, at individual level, the data also can achieve some progress for individuals, not when we take, like, at the grand scale? I mean, I completely agree with you that this is a big step for us to kind of being able to look at all this data that is available. But if we just take households, do you think that there will be a shift eventually in people's understanding that maybe, the fact that you replaced all the bulbs does not give you the right to keep them on all the time?
Yes, right. That's a very good question. And it is so close to like real life situations, meaning if we can make progress in this aspect, the question you have asked, it has potential to help a lot, rather than just somebody sitting on as a decision maker versus people who are day to day, hour by hour using energy. If they can do the decision of saving it themselves, then it's definitely a very good question. So I have also thought about this question quite a bit. And I think one solution I have been able to think about is how can data help is if utilities are able to provide individual level insights on the utility bill. Like on utility bill, top right corner of the first page, if they write things like last month's usage this much, this month's usage this much, and your electricity is coming from your 30% electricity came from coal power plant, 40% came from wind, and remaining 40% came from solar. So this kind of gives them a real life, or how should I put it, like a very tangible view into their usage. So, for example, the bulb replacement example you were mentioning about, it is actually possible to take just the power meter data and then do non-intrusive load modeling, which is kind of a fancy way to say that we can take your overall house consumption data time series and then run some machine learning algorithms which can tell us this much energy was spent on fridge, this was on AC, this was on light bulbs, and this was on fans, right? So if a visual plot can be processed by the utility, and then they plug it into the very first page of the electricity bill, that's give them a visual reminder or at least insight into what is really happening, right? And if that's done like on a regular basis for a year or two, along with maybe a couple of notes in the utility bill itself, I feel like that could be an effective solution to help people understand that at times their well-meaning actions of changing the bulbs kind of ends up being even more energy consumption process instead of what it was originally intended to be. So
so hopefully we can with this kind of educating and empowering people in kind of understanding their energy consumption better, we could actually achieve behavioral change. Yes. So I wanted to also talk to you a little bit about diversity and inclusion. And as you mentioned, you have studied engineering, which I can't imagine there were many women in your class, but maybe there were. So tell us about this. And in your opinion, do you think we have a lack of women in STEM? Well, the reason I ask this question is there were people on this podcast who questioned that. And if so, if you think that there is a problem, then why do you think, what are the underlying reasons for that? Why is it that we have the problem?
Okay, sure. So first I'll answer your first question about my own journey into electrical engineering. And I have kind of a funny anecdote to share here. Mm-hmm. So I was graduating from high school and got admission into this college. And in India, where I got my undergraduate degree, it's kind of mandatory to pick the major in the first semester, or even before joining the first day of the semester, you are like pinning down the major. So the choice was between electrical engineering and computer science. And to me, it was both the subjects or both the fields were equally appealing. And I was like, not sure which one should I go with. And then I asked for some advice around, and turned out 95% of my neighbors or people who I knew at that time were like, electrical engineering is not for girls. You're not going to be able to work with machines, And so, and it was the way I was challenged, I actually took it up as a constructive feedback. And I said, okay, let me show you, how can we do that? Mm-hmm. So though I wanted to at some point take computer science major equally as much as electrical engineering, but then I picked electrical engineering and just kept going with it. So it was like 10 years ago, and it was developing country setup. So I think things have changed and progressed. And at that point in time, the class ratio was like, we were 17 girls and some 70 guys. So it was less than 20% for sure. So that's how I got started. And to answer the second part of the question, in my opinion, yes, we do have a lack of female representation in in STEM field. But we are talking about data-driven world, and let's talk numbers. So according to World Economic Forum, only 22% of AI professionals globally are female, compared to 78% who are male. So data is saying the same. It's I mean, opinion as well as data, it's something which it's very, very, I would say it's kind of, there is nothing to debate there. Mm-hmm. It is something that lack, and the question is about how do we solve the issue. So there are many aspects to the reason of why it is happening. They can be societal, cultural, or even economical. So if we look at the developing world countries, majority of the young women cannot afford education or have household work responsibilities which keep them from going in education field at all. And if we talk about developed countries like US, UK, Western countries, the reasons are sometimes unconscious biases or lack of role models, or sometimes lack of mentors or affirmers who can say that, yes, if you're dreaming of being a scientist, you will be able to. Or and at times it's like it's preventing young girls from even dreaming about STEM careers because they can't see the role models, or they have no backup or nobody backing them up or affirming them that, sweetie, you want to do it, you will be able to do it. If somebody told a 7-year-old girl this affirmation, it is going to positively impact their determination to grow in the field, right? Very beyond. So those are the kinds of reasons. So I think it is a larger question of, as you had pointed out earlier, it's a larger question of diversity and inclusion that needs to be answered. The deep-seated cultural or society norms that have been in action for centuries, that need those norms and those unconscious biases are also a major part of the problem which needs to be addressed to make it happen and to make it an equal playing ground for all the humans.
Mm-hmm. Yeah. I mean, I just want to make a footnote here that obviously there are other underrepresented groups. We're talking about women specifically, but if we also kind of split that into, say, race, that the situation will be even worse, obviously. And we're not talking currently about other minorities because I just want to concentrate on one aspect, and that's women. But clearly there are the problem is a lot broader, right, than the one that we are discussing at the moment. So you mentioned so we discussed the reasons. So what do you think we can do apart from maybe, so you mentioned role models, having role models, that's one solution. So what would be maybe other ways of improving the situation in your view?
Yes. So it's not going to be a silver bullet solution. It has to be like a bunch of solutions coming together from different directions to make it happen. So it can be either bottom up or top down. So when we talk about building more role models, it's kind of bottom up solution where girls growing up can have aunts or some neighbor or some acquaintance who can say, oh yes, I work in this field, I'm working as a data scientist, and then she draws inspiration from them. And another bottom up solution is to just the mentorship and affirmation from early age, rather than always giving, and I'm not against giving pink color to girls, but let them make a choice. Why always just pink? Be it blue, black, white, like just show them the sky is the limit. It's all open for you. You get to choose what you want to do. So that kind of nurturing that mindset from the beginning is absolutely crucial in building the pipeline after 20 years from now, when little girls are getting into the professional phase of their life. So those are the grassroots bottom-up solutions, which as a society, as an individual in the society, we can try and build. And then the second aspect of it is really top-down, where huge organizations, it has to come from leadership, really from the organizations, that if they have to make it a priority and involve it requires involvement on various stages, starting from HR to managerial level to day-to-day colleagues interactions. This has to get really, really like deep down into the mentality of every single contributor to the organization, that this matters, that diversity and inclusion is a serious issue for female as well. I mean, we are, as you have pointed out, we are talking about a subset, which is just the female representation right now, but it has to be like as an organizational value, or it should get blended in the culture of the organization that there is an issue and this needs to be addressed, and this needs to be addressed now. So that the unconscious biases faced by women in the room, women on the table, they should go away. So that's a top-down approach which needs to be implemented, for which there is a lot of work to be done to increase the awareness amongst them.
Yeah, so you mentioned mentorship, so I just want to kind of go a little bit deeper into this subject. So we discussed on this during this podcast, this issue with mentorship, and like for example, when I look at my mentors, they were all male. all white male. So do you think that the mentors, like who the mentors, should the mentors be female necessarily, or that could be basically anybody who like you were saying should kind of get women into this, or help get women into this mindset that they can do, this is something you can do. So do you think it helps to have a female mentor, or you can have basically anybody could be constructive diversity mentor, even if they are the representative of majority group? So what's your position there?
I think I am leaning toward the latter option, where anybody could be the mentor, and as long as they are thinking themselves constructively, they can always instill this confidence in the mentee. Because if you think about the practical implications of constraining it to just female mentors, we are going to lose a bunch of mentors, meaning if we want to serve a whole female junior population in a company, then one-on-one mentoring, how many female seniors can you really find for them? So in its practical aspect, it will be difficult that way. As well as we don't really want to create a chasm, right? We don't want to make female feel that, oh, you can only reach out to female. The only understand you is a female. So instead, it's a level playing ground. We all are just humans trying to encourage each other and help each other grow. So for that reason, it makes more sense to let it be the flexible playing ground. A female or male mentor, they just have to be open-minded themselves, and then pass it on to the mentee.
Yeah, thank you for this perspective. I think I completely share your feeling that it has to be. It can be anybody. Yeah, it can be anybody as long as they inspire people to look beyond their current skill set and explore new things. That's important. So you already, coming back to the skills, you already mentioned that a lot of people feel that there are a lot of barriers to starting in data science, and you were saying that you just need to learn something and then try to expand. But I just want to kind of again go a little bit deeper into this subject. So some of my students, for example, are executive students, and they are not trained in data science, right? So and they are currently considering, should I get some coding experience? Should I learn some coding? Should I learn Python? Should I learn R? So all these questions, they are very, very real for them. So how important do you think the ability to code for working in energy and sustainability? So do you actually, imagine that you, again, starting from scratch. So should you actually learn Python, or should you maybe invest some time into learning some fundamental sciences like mathematics or statistics? So what would help more?
Okay, so I guess I will stick to the assumptions that the group of people we are talking about are the ones who want to get into data science field in commercial or real life companies instead of just research. So if it's getting into research, then it's absolutely important to brush up on mathematical and statistics. Those are kind of basics. But if they're looking into somewhere lying between research and industry, for example, my profession right now at National Renewable Energy Laboratory, it's not pure research, but it's not pure industry as well. So it's an overlap of two. So if that's the kind of environment they're shooting for, that's where they want to work, then I would say learning technical skills like programming, R or Python is a good way to start. And also, one thing to point out here is that it's important to know what kind of role they are working towards. So if they want to land a job, let's say saying software engineering lead for energy sustainability application, in that case, they need to hone their coding skills to intermediate or above level. But if they're looking for a project management or program manager role for a team which is building a code base for energy modeling, then they don't have to be pro programmers. I mean, as long as they have basic understanding or conceptual understanding of the whole thing, that how does the software pipeline go? Okay, we build it, we iterate over it, we do this 2 weeks scrum daily scrum or 2 weeks sprint, just getting themselves acquainted with the terminology and conceptual understanding of how does the product cycle goes for a software product will go a long way if they are shooting for a role into project management or product management. But still, so to answer your question, I think technical skills are important. It's the level to which they have to hone them, which varies depending on the role. So if they want to go for project management role, just the basics of programming, yes, I can open a Jupyter notebook. Yes, I can run basic 2 functions. That is good enough. And from then on, they can lead the team, or they can contribute as a project manager to the team, right? Or on the other hand, if they want to get into like real solution building, then technical skills or coding skills are absolutely necessary, I would say. But I don't want it to sound discouraging, It's like, if they, so I guess I'll just take 2 more minutes to clarify it a little more, because I feel like I'm not leaving any answer which gives the right directions. So let's say we want to get into a company which specializes in building a software tool for energy modeling, then yes, software engineer role there requires a lot of programming skills. But if you want to get as a project manager or project engineer who has to speak to customer, who has to define project requirements, and who has to just oversee the team of engineers who are actually coding, then you don't have to be big expert in coding. So those are the couple of nuances to keep in mind. Wow.
So obviously, in the current environment, we also cannot avoid the discussion about coronavirus. I think it affected everybody, and a lot of people are still confined to their homes for various reasons. So not all countries kind of eased the quarantine measures. So, do you think data science and AI can help solve the current crisis, especially from the perspective of sustainability, which is very, very important now, because a lot of us are now at home, and we've seen various issues with, energy consumption. So I guess the energy consumption's changed, right? But in terms of sustainability, we also have seen some positives and some negatives, like, for example, we see that a big improvement in terms of pollution, right? So we don't have as much pollution in terms of big plant pollution, but at the same time, we probably are consuming more plastics. So, on the sustainable side, it's really like hit and miss picture. Like from the energy perspective, what is happening currently? Are there any kind of trends you can share? Because I personally wasn't following that much, so maybe you could kind of shed some light on what is going on, and maybe to what extent the data science can help in the current situation.
Sure. So I think in terms of trends in energy industry, almost all the countries have seen load drop because of the whole industry sector or manufacturing sector or big office buildings are not operating as they do. So those drops are sometimes it's like they are dropping the coal. Let's say the coal plant's consumption or production itself is getting dropped for 24-hour ahead planning or 48-hour ahead planning, which is helping with reducing the emissions. On the other hand, as you were pointing out, that consumption patterns for residential users are changing drastically because of more time spent at home. And so, yes, initially I also dealt with it where I tripped my circuit with 3 monitors, 1 GPU running at home. I got it home. And then, so I guess in terms of data science being able to help with this kind of situation, in long term, definitely, yes, we can capture the patterns or we can capture the data of how the load has shifted, not just at a utility level, but also residential level, and understanding that how do consumers behave when the whole life cycle is totally different. So that will be like, we will collect the data now and then draw insights when we have 6 or 8 months or a year worth of data. So that's long-term application. And I think in short term, I think tying back to the point we were discussing, that making consumers more aware of how their patterns are changing, and if they are changing in the negative direction, then just giving them enough signals so that it comes to their notice. Because once they are notified, for sure, many people are interested in taking steps to make sure that their carbon footprint is not getting worsened, if not better, right? So
I'm particularly thinking that, like when we talk about organizations, even big organizations, right? There is much understanding in organizations that you need to save energy, so there are efforts to do that. Like, for example, I know in my office, if I sit there for, I don't know, maybe half an hour, my lights would go off and I need to make some movement to turn them back on. So clearly this does not exist in the household, right? Everybody is kind of making their own decisions about energy consumption. So there is a lot of heterogeneity, I guess, in how we approach the problem as individuals, rather than, it seems to me that at organizational level, it's a lot more efficient because a lot of decisions kind of made for employees. Whereas like if we're working from home, you're in charge of your own energy consumption. And I think on top of all other problems that you are dealing with, that's probably kind of at the back of everybody's mind, not at the front of everybody's mind. So, and kind of to expand on that, like, what do you think are the major challenges the energy sector is facing today? So obviously, I mean, we've talked about the consumption part, like, but again, zooming out to the whole sector, what do you think are kind of the major challenges, maybe for the foreseeable future?
Sure. So when we talk about electrical industry, it is no more a secluded or isolated industry. It's right now the way electric vehicles are picking up, their penetration is projected to grow a lot in coming 10 years. Transportation and electricity sectors are getting more and more intertwined. Same way, if you think about urbanization or urban built environment management, waste, how do you manage the waste, or how do you manage the heating? How do you manage the overall electricity consumption? They are all so intertwined that the operations need to be coordinated or thought about on systems level. So in terms of challenges, they are also presenting challenges the same way, because as the electric vehicle penetration increases, when do people charge it? Nighttime, daytime? It is going to shift the load curve. What if the people start to sell energy back to the grid when the prices are peaking? But when the energy prices are peaking, it means at the same time, if all electrical vehicles just plug in and sell energy back to the grid, okay, I want to make money. In that case, how do you manage the grid in that situation? So that's like one of the challenges. Then second challenge is the aging infrastructure. Right now, distribution system in all the developed nations, it's like years, century, like if not century, multiple decade old systems right now. So in that case, do you actually have to replace the infrastructure, or would it help to install solar panel on each house, and then you don't have to, you can defer the upgrade of the distribution feeder or the poles or the transformer on the distribution level? That's one of the major challenge. Then the third one being large-scale renewable energy integration. We have seen few islands kind of succeeding in bringing their renewable energy generation to 80% and above. But for larger countries like US, it is far away from reaching that number. As more and more renewable energy starts to get integrated to the power grid, how do you manage the uncertainty posed by its generation? Do you add more batteries, or do you go with more peak shaving plants, but they will increase the emission? So that's another challenge. And that leads into the challenge of battery or energy storage modeling. So right now, it's a hot research topic area, that how do you model the degradation of the battery? So if you're installing a large battery pack and hoping that it will last for 20 years, maybe the way you are using it, charging and discharging it, it will only last for 12 years. So economic calculations will be off by 8 years. So understanding how does this battery storage degradation works with how you actually use when you need to use the battery, that's another research area which poses the challenges which needs to be solved. So
sounds good. I mean, maybe you could you could tell me something about that. I often think also in terms of like electric vehicles, right? So we normally there is a perception that electric vehicle is a lot more efficient, and it's a lot better for the environment, which it's hard to disagree with that claim. But then when I'm thinking about how you dispose of the electric vehicle, because like my feeling is, maybe I'm wrong, that this kind of shelf life of electric vehicle is a lot shorter than the traditional vehicle. And when we dispose of them, it's I think it creates a whole whole lot of issues. So is there, I don't know whether you've looked at this, but I mean, if you have looked at this, maybe you could tell us a little bit about, how, is it really a problem to dispose of electric vehicles, and especially like the battery, like this issue that you were talking about. I mean, I guess that's not only about buildings and devices, but potentially also about vehicles.
Yes. So I think in terms of electric vehicles, I have not read into the disposal of electric vehicle body, but about the battery specific component, disposing them of is still an area of research, which is because lithium ion battery, which is kind of being used largely for the application. How is that? Currently, they have been for many, many years, they have been disposed of just like that, meaning no processing or post-processing to make sure that it's hazardous. And there are, there is another line of research where they are trying to understand the batteries which come out of the electric vehicles, because they no longer serve, can actually be used for energy applications, for building utility backup batteries, because need to pump out the power as fast as they do for electric vehicles. So second life of batteries is another area which is being researched. So let's say I don't have strong opinions on how would it turn out in long term, but there definitely are projects or efforts going around understanding this life cycle of how will the vehicles will be disposed, as well as how will the battery, which is potentially in hazardous waste, will be handled.
So, and the kind of adjacent question to that is, you talked about kind of the future and the issues the challenges that the sector is facing, but how can, in your opinion, what is the future of data science in application to energy and sustainability? What would be the hot topics? How will it develop in the next 5 years, in your opinion? I understand that this is a speculation, but yeah. If I asked you to give a prediction of what it's going to be like, what would you say?
I would say one of the hot topics right now is urban built environment energy efficiency, and it has many aspects to it. So in coming 5 years, it will only grow intense because urbanization is going to keep increasing given the past decades, many decades trends. So that's one of the applications of data science or AI, where understanding the orchestrated operation of energy, waste management. I think I was covering this topic earlier, that how do you manage the whole urban environment as a whole sustainably? How do you manage the transportation aspect of it, or heating or cooling? So bringing those all together, data science has many, many applications for sure in coming 5 years to be explored. And if you think about it, subparts, so just the transportation alone, yes, as the EV penetration goes, its interaction with the distribution grid in urban environment will be required a lot more people to contribute to that area as well.
Mm-hmm. So yeah, we're almost at the end of the interview, and I just have one last question for you. And this is a question that all guests complain about, but I ask it anyway. So the question is basically, it goes like this. If I ask you to recommend one book and one film, what would be your recommendations? They don't have to be data science related, but something that inspires you and something that you keep coming back to. Yeah.
Okay, so I'm not gonna complain. I'll directly get.
Yeah.
I guess the book will be Ray Dalio's Principles. I think it came out in 2016 or 17, and personally, I found it to be very useful. So embedded in his journey to building a successful hedge fund, which is not really related to energy field, but the principles and the approach to building and rediscovering them he presents, I found that to be pretty useful for that book. And then for movie, it's a 2015 movie. It's called Joy, and I think Jennifer Lawrence was actress in there, and I recently rewatched it. And it's a journey of a woman in tech entrepreneurship field. So she was building some magic vacuum cleaner. It was like a product for cleaning houses, which is again not related to energy, but I like the inspiration of how a female grew into an tech entrepreneur by taking actions and self-motivated female entrepreneurship field. So I think that's something I like to. Yeah, I like that movie.
Mm-hmm. These are the great recommendations, actually. So thank you so much for finding the time today to talk to me. And you have provided a lot of insight and cool ideas to people who would like to work in energy and AI. And so thank you so much for being with us today.
It's my pleasure. Thank you for having me.